So now we're going to go ahead and actually continue the next steps of our code base or for this application. But before we do that, you've noticed that this is getting a bit long and there's quite a lot of details coming in here now. So what we're going to do is kind of structure this application a bit. So instead of having this one monolithic big main.go file, I'll talk you through how to create and set up and work with sub packages. So we're going to go and let's create a sub package, call it webhook. And inside that, we're going to create a new, I should have created a folder, not a file. So call that webhook. And inside webhook, I'm going to create a file, call it webhook.go. And I'm going to say that the package is webhook. And inside the package webhook, I'm basically go ahead. So let's go and let's just copy paste pretty much all of these things in this webhook.go file, right? So all these modules and everything would be automatically imported for you, and it should all be good. But one thing you've noticed is that it's unused. Basically, it's not being called anywhere. But that's not the problem. What I wanted to show is that I need to be able to call this function from this webhook sub package within my main module, right? So in order to do that, what I need to do is I need to add an import for this sub package in my code, and I also need to capitalize the first letter of the function. This would ensure that this function can actually be exported and used from another module, right? In this case, the root module. And to import it, what we need to do is just do the module name. So in our case, the module name is just github.com/github-bot. Now this is something we did right at the very beginning in the first video when we initialized our module. This is the name we gave. But any sub package that we have in this module, they just need to be appended after the module name. So here we just need to call it like webhook. And here, if I change it to W, you'll see that VS Code already comes up with the recommendation, and now I can actually invoke it. So now going forward with our application now, the next step really is for us to kind of find out what are the files, right? Get a list of all the files that were changed as part of this pull request. So to do that, we're going to need a thing called GitHub access token, and I'll show you how to set that up in a bit. But before that, I'm also kind of going to talk you through the concept of n files. So we're going to create a .n file, and we're going to create an n variable here called GitHub token, because you don't really want the token to be lying around in your code, right? Because it's access token, so there are security issues, right? Somebody can take it, so it's a very bad practice to just leave it in your code hard coded. So I also recommended to put it in the n file like this, and you actually paste the value of it. I'll show you how you can get it now. So you basically need to go to your repository or your account in GitHub, then go into settings, open it on a different tab if you want, and then go all the way down to this developer settings. Once you're in developer settings, you can then go to personal access token, go to classic. I already have got it, but you'd want to basically generate a new token. And for the new token, just give it a name, description if you want to. And basically just do it for repositories. Account permissions are there, like what exactly you would want to do it for. But in my case, I just did it for my GitHub bot. It's a personal access token, and it's just for the repo. Well, actually, let me just check something. generate a new token classic. Okay, yeah, it's just a different interface. So if you go to the classic one, that's what I've exactly done. So just give it a node and just choose repo as your scope. And that will basically allow you to generate the token. And once you've generated the token, it will get displayed in here. So copy it. And after you've copied it, just come back to this end file that I showed. Just paste it in here and then you'll be good to go. Right. So now in my case, I'm actually going to go forward and show you how to kind of load data from the end variable. So to do that, what we need to do here is, let's just do it right at the very beginning, right? Even before, okay, no, let's do it after we receive the webhook request. After we receive the webhook request, let's just do and we're going to use this thing called go.env, right? And we're going to say .load. So what is this go.env? So go.env is basically an interface that would allow us to use the method called load that will load. That's basically looking for file .env existing within the root directory, and if it finds it, it's just going to load all the environment variable that exist within it into the memory basically, and then we can access the env from there. Right. So now that we've loaded the env, we just want to again do the error handling. So if you're new to Go, you're basically most likely wondering, like especially if you're coming from something like Python, why am I repeating this error handling again and again, and instead, like, why don't I just put it into like a common function? Now the thing is that this is very idiomatic in Go, right? To do error handling like this, as in it's very natural. So it's something to just get used to as you're working with Go, because you'll realize as you refactor or try to refactor it and make it common, you'll realize that you're going to have to return an error regardless, right? You're still going to have to do the error handling, so you're not really reducing any code from that point of view. You can add a wrapper over it, sure, like a common function for it, sure, but you're not really going to reduce any code. In fact, you're most likely going to be adding some code. So we're just going to do some error handling here and do a return. Just print something in the standard output saying error loading.env file, right? And now we're actually gonna store the token that we defined from the env. So for that we need the os.getEnv method, and here we just literally need to provide the key that we defined in the env file for the GitHub token. And we will also set up let's set up a var for supported languages, right? And we will call it, so it's going to be a string slice, and it's, let's give it, for now, let's just say it's a Go, because we are going to actually, so the reason for the supported language is that I want to add a logic here to say that if the source code is a Go-based source code, then use that and submit that to the large language model to get some feedback. Because you have seen that I've already added the readme.md file in my pull request, and I want it to be there just to get around it, right? Sorry, just because it's already there. I just want to show that we can exclude that based on supported languages parameter, which is where I'm going to define that, right? If it's a Go-based file, only then take the content and send that across to the large language model and get some feedback on it. And coming back to quickly, so this is in GoLang, this is called a slice basically. Slice and arrays are slightly different. So one of the fundamental difference being that slices are dynamic, right? So I don't actually have to give a size in here. So if it's an array, I would have to give a fixed size, and I would actually have to give the 3 elements in there, right? But it's dynamic, so it can grow over time. And slices are actually much more useful based on my work experience so far. Slices are much more relevant when you're working with a real world case, right? Because you're always trying to initialize a slice and then keep appending to it. Whereas with an array, it's fixed size. It's like a constant. That's the most pressing difference, I will say. And let's just actually add some more. So let's say TypeScript. So if it's a TypeScript file, JavaScript file, or let's say if it's a Python file, then I'm going to pass that information down, or actually pass that content down to the large language model for some, improvement or suggestion. So yeah, so now let's go and actually update this code to use it. So, right. Let's actually, so ultimately, first thing we want to do is get a list of files back. And that list of files is basically going to be returning an object per file with some information. And the information is basically going to be just the file name and the raw URL for the file, so that we can then hit the raw URL and get the actual content out for that file, right? And let's say we're going to add a function for it. Let's say get files, and we're going to pass a few things into it. So let's go and define this get files function. Now the get files function, you notice that I haven't capitalized the G, the first letter of the function, because this one doesn't really need to be exported anywhere. We are going to be using it internally within this package itself. I don't need to actually export it and use it from main, so it doesn't really matter at this point if it's capitalized or not. So capitalizing the first letter, again, just to emphasize, is a way in Go to export things basically. Right, so what we're gonna have to do now, first, let's go and I'm going to populate the arguments that need to be passed into this function as we go, just so that the context is more clear for them. So let's first create, right, what's the URL where we're going to send the request to. So let's see if we can actually see that in PR. So let's go to the files changed. Right, so this is the file and I can see the content, but this is the URL. So what we need to do is basically populate this. So let's copy this down and come in here, and let's say this is our string, right? But we want to dynamically populate it because the PR is not always going to be the same. You could hard code this bit, I suppose, but still dynamically populating is better. I would prefer to do that than hard coding it. So to do that, we want to use the printf function. This will make it basically format the string with the passed in variables in this case and store it in a variable. So let's go and put this inside a quote first of all, and we will get rid of this. We know that this needs to be a number, so it's a %d. We'll get rid of all of this in here, and let's do a %s because we want to replace that bit. And in here we're going to pass in, let's say, full name. We know we already have that information, and we also know we have the PR number information, right? So let's say our first parameters here are going to be full name. It's going to be a string. We're going to have PR number, which is going to be an int, and after that we're going to actually, let's say, generate the request. So I'll come back and populate this right at the end. So this is the URL. Now we're going to actually set up a request, in particular a GET request that we can use to send requests to. So here we're going to use the function called new request from the HTTP module, right? So what this does, this is actually not going to send a request. that it's going to create a request, right? And it needs the informations like method, URL, and body. The body is actually not really relevant in our case. We're going to send a get. So if I just go into so this is how you can go and look at the source code if you want to, by the way. Just if you're in VS Code, right click it, click on go to definition. It's very handy. So you can see that it says the body is optional. And the body is most likely you really need with a post request, not with a get request. So in our case, we can just pass it as a nil. So first thing, let's put the method. And then we're going to pass in the URL that we just defined, and here we're just going to do nil because in our case it's a get request, so there is no body. And we also need to set a header for it. So we're going to go and set a header to this request, and the header is basically an authorization bearer token. So if you've worked with other cloud platforms, then you'll probably come across it, right? Like GCP. So GCP is pretty heavy on using bearer tokens. So this is the other thing we need, which we also know we have. So let's go token, and let's say it's a string. So this will just allow us to, when we're sending the request, if we set this as header, we're actually not going to run into any authentication issue. So now we're actually gonna write the code to send the request. So we've got, again, HTTP module, and we're gonna use the default client. So the default client is basically what you want to use to interact with request when you're creating a request and then sending it off, right? And you want to use the do method of it and pass the rec in there. So what does the do method do? So the do method basically, as it says here, sends the HTTP request and returns a HTTP response, right? And in our case, that's what we want to do. So the errors are expected. Let's do some error handling again here. So if the error doesn't equal to nil, then we're going to throw in HTTP error just like we did in the past. So HTTP error. And it's going to be, so basically the same thing that we're seeing it here. So we need the writer. So the writer again needs to be passed in. So let's go and copy this over, and we're going to pass this in here. So now that we have the writer, we can pass the writer in. We're going to pass an error message, and in the error message we're going to say fail to get response, fail to get response back from GitHub URL. And we're actually gonna throw a HTTP status. Let's do like a forbidden in this case, because we definitely know that it can be found, and we definitely know in this case it's not going to be any read related error. So it's most likely going to be a forbidden error, like in case I've deleted the token or it expired or something like that, right? And let's just do our return for now. The next thing is with the response. So we need to read the response, and we have done something very similar previously, right? In here. So you're just going to go and copy this, because we need to do literally the same thing. I'll come back to the whole supporting language that I spoke to, just bear with me. So here what we want to do is, instead of request body, let's do resp body, and we're going to be also doing some error handling here. So let's go and do if. Another advantage of doing error handling like this, like I could also do something like panic and error, right? That way I don't have to return an error or anything like that. However, you shouldn't really use that as often. It's really good to be able to do good error handling. It will really help when you're trying to troubleshoot or something's not working, especially in the nature of applications that are running nowadays in the cloud, right? A lot of microservices, a lot of interaction going on between service to service. So you really want to have some good good level of error messages and error handling in place. So here we're just going to go and do again another HTTP error. Let's do a writer. Let's give a message this time, fail to read response body. And then this time it's going to be a bad request again, or due to a bad request again. So we're going to throw that and just do a return here, right? Now we're going to inspect the body again, just like we did last time around, and we're going to see how the data is kind of structured in a JSON format, and we'll pull out the relevant fields that we need. So let's just do again something like that, body string, and let's just do string body, and we just do the print line, just pass the body string into it. We can then look at it, just in case again there's 20,000 parameters and we can't see them all. But before we do that, let's now go back and actually update this get files function too. So we know already have the payload dot, it was repository dot full name. We have the PR number as well, pull request number. We have the GitHub token that we got from the envar. We have the writer as well with us. And JSON full name is a string. What is the repository full name? We're passing the PR number, we're passing the GitHub token. Oh, sorry, GitHub. Oh, did I call it GitHub? Let me have a look. Oh, yep, that's a typo in there. Let's do GitHub token, which we're being used in here, and I've got get files method. What's the complaint in here? Let's have a look. Used as value compiler. Oh yeah, of course. I see the problem. The problem here is that I'm not returning anything for the files. So actually let's get rid of files for now, because we actually haven't dealt with most of it. So let's get rid of all of that actually for now. Just call it like this. Yeah, that was the problem. Right, so now if I hit a breakpoint, so if I run the code, oh actually before I do that, let me actually also add the supported languages logic in, right? So we are going to, I'll come back to this actually, because I think, yeah, I just want to take you through every step rather than just go jump into something straight away. So let's just go ahead and run it. So if I launch the package and it runs, and if I hit my breakpoint, let's say to get files, and then we're gonna hit the breakpoint somewhere here. Oops. Oh yeah, and the piece of the puzzle that I completely forgot is that this is a module that currently doesn't exist as a dependency within our Go module. So what we need to do is just do go get. So anytime you're importing or using something in Go and you see that like in your IDE it's getting flagged with the red highlighting underneath, it's most likely because you don't have the dependency register for your Go module. So now if I go and run it, it should be fine. And let's actually just do that. We want to inspect the body string format of it at least. So let's go ahead and go back to the pull request. We're going to go here and we're going to say close the pull request, and that is going to, yeah, okay, because we closed it, so there shouldn't be any body for it. But if I go back and now reopen it, we come back down to the code. Not found. Peer trigger test is ready for review. Okay, something is not going right in here. Let's have a look. So we probably want to hit a breakpoint then. There's something not going right. Peer. Go close it. Go back down to the code. And then we want to kind of reopen it, right? Let's see what's going on. This is a good example of how things can be in real life. Basically, when you're working with something the first time. So our URL is api.github.com, pro platform engineer, GitHub peer pool 7-files. Okay, great. So you're saying that this is returning a 404, huh? Okay. Interesting. Maybe I should have handled for that error as well in here. But anyways, right, why is it coming with a 404? Oh, of course. I must have got rid of the, oh no, because I copy pasted it, the repos. So the api.github.com would need a repos parameter, and this is actually pulls. These are all plurals here in the API. I think that's the problem. So let's go back and let's close this PR once again, and we'll go back in here and we'll launch the package. Once it's up and running, we're going to go and reopen the pull request, and this should now, oops, wrong one, go in there. If I go forward, I shouldn't get a 404 now. Yep, got a 200, so let's just go all the way through. Yep, there you go. So now I got the body, this is the content. Okay, it's not very big. So what we need here, so what are the properties? So we would want to know the name of the file, because we need it to actually get the content for the file. There's a blob URL, right? There's a raw URL. Then you've got contents URL, and there's the actual content, but that's not very clear. So what we're going to do is really just create a type for the file name and the raw URL and use that. So if we come back down in here, let's go back and create a new type. Oops. So the type is going to be, let's say, file, and it's going to be a struct. So for every file, we're going to need file name. It's going to be a string, as we can see. And the JSON for it is also called file name, lowercase. And then I'm going to be also looking at the raw URL. String, JSON, and then this we can see is raw URL. Right, so that's my file type. So now I'm going to come back down in here. Let's stop this. And I know that I actually need to, similar to before, we're going to initial or declare a variable in here, call it files, which is going to be an array of the file type, or a slice of the file type that I just defined. Now that we've got it, we just need to do some JSON on marshalling. again, very similar to the previous method. We just pass in the body, which is basically a byte slice containing JSON encoded data, and we're going to pass a pointer to the file slice in here, and we're going to do the error handling like previously. Oops, doesn't equal to nil. We're going to do http dot error. Let's pass in the writer here again. To fail to parse JSON data from response body, and we're going to go and do it status bad request. Yep. And now one thing we're going to do, let's look at the return. So if all that is good, so this is I'm expecting, so this is an array, right? So I can have multiple files as part of the PR. And I'll try that out in a sec. I'm just going to copy some of this code from here, store it into a main.go file, and add it to the PR. So then I've got multiple files. But what this JSON unmercial, other cool thing about it is that it will automatically find all the keys that we have got based on the type definition in here. And it's going to notice that there's multiple objects in an array containing the same information. So it will automatically map it to an array for this Go type as well. So we don't really need to, handle any array appending initialization of an array and append data into that array for each of the file objects manually. It's all done through JSON unmercial, and we'll see that very shortly. But before that, let's just return. So now we can actually we want this method to return files, and we also want it to return nil as error if it's come up to this line 100 here, right? But it means we also should return now, because if I don't return now from here, then Go is not going to like it, and I'm going to run into an error, because I can't return at the final line but not have these return statements populated, because the function must match the same returns regardless, even if it's an error. But in this case, what we're going to do is our files array is going to be nil, but we know that here there's going to be an error, so we'll return that. Ignore the red for a bit. It's because I haven't defined the actual return during the function definition or declaration. Let's do nil and let's do error, and here I'm actually going to go and say that the return is going to be of file and an error. Now all these red highlights are magically gonna disappear. And now I can actually do what I was trying to do first time around. But of course I need to then handle the error. So let's do if error doesn't equal to nil, then we're going to, I guess then we're just going to, say that failed to get. So let's just do printf. So let's just say something like failed to get files. Oops, get rid of the pipe files due to error. Put a %s in here, and let's just do error. And here we're just going to return. So the function exits. For files, we are not really going to do anything now. I just wanted to show you guys how it looks like. So we're just going to do files for now, okay? Just so that Go is happy. And let's just go run it. And this piece of code should not run anymore, even if I close the PR. So it should be good. And let's go and hit a breakpoint here. Then we're going to walk through it. So if I go in and close it, and let's actually reopen it. We go back to the code. You can see we're here. So let's go step over it. And now we can see our files. So our files array has only got one item. And in that item, I've got file name and raw URL populated as expected because of the file and because of the unmarshalling that we've done in here. Now you've got YAML and Marshall as well, which basically deals with YAML. JSON separate. JSON deals with just JSON. But yeah, it's YAML in Marshall works in a very similar manner to this anyway. So now let's go ahead and actually add Go to our test repo, right, into the pull request. So if I actually go in here and switch to the code for the test repo for a sec, let's create a new file. We don't really need to set up the Go environment or anything in here. Let's just copy some code in from our existing code. So let's just actually, let's just copy paste all of it that we've written so far. And we're going to paste that in here. And let's get rid of something, so we don't really want it. Let's just use the natively built-in Go modules. Let's get rid of the env that we're dealing with here. Not that it matters too much, but yeah. Now let's go and kind of commit this so that it's added to the pull request. Yeah, git status, git add a. And let's do git commit added main.go file, and now we just do that, git push. So this is now on the PR. So the next time I open the request for the PR, the body is actually going to have information about not just the readme but the main.go file as well, which is what we're going to use to send off to the large language model. But let's now resurrect back this line in order to do that. So I've got supported languages. So I'm just going to go and add in some logic in here to kind of make sure that so let's actually get rid of this. So now we're going to loop over this list of files. And for each of these, we're going to go get the content of it. We're actually going to check first if the extension of that file matches one of the extensions that we've defined in here to the supported languages. If it doesn't, then we are not really going to bother any more further with it in the application. But if it does match, then we want to go ahead and actually send the content of that file to the large language model in AWS Bedrock. So let's loop over it. So this here is just because you know how you've seen with GoLang, if you give a variable name and then don't use the variable, Go doesn't like it, you run into error. This is just a way to kind of get over that without actually having to use that variable. So it's an unnamed variable here. It's basically just for the index that's coming in as we're looping through it. But we don't really need it in this particular scenario. So we're going to loop over this files array that we got back. We are going to create a variable called file extension, and this is going to be, we're going to use the strings module. We're going to split it. Works very similar to other split methods on a string from other languages. I'm going to do file name, and let's split it on dot. So this way we're just going to get the extension for the file. However, this is gonna split it into an array just like it would in other programming languages, so we need to make sure we get the last item for it. So let's do something like, but we can do that in the if statement itself. So let's do if slices. So slices I'm using to actually run this if logic. So this is a way to compare if the variable or the slice supported languages is actually containing, or this particular file extension matches any of the element that has been defined within the supported languages slice. That's what we're checking in this if statement, right? But obviously to do that, I need to get the last item of this file extension array. Let's do -1, right? So this is a way to get the last item of an array in GoLang. And then if that's true, then I'm going to basically go in and run or call the function that will actually get the content. We haven't defined the function yet, but I'm just going to do get file content and leave it empty for now. We'll define it very shortly. But essentially that's the idea. That's why I wanted to define the supported languages slice. So now let's go down in here and we're going to do func get file content. Again, doesn't need to be capitalized, the first letter, because we are using it internally. And we will define it as we go. So the file content is basically going to be very similar. So let's go and copy this URL. So the URL for this through the API is going to be a bit different. So we are going to, now we know the file, we can just do something like contents, and then we pass in string, which is going to be the actual file name, and then we need to pass in the query param ref, which is basically the git commit. We have it stored into the payload struct, into the payload pull request type as a from the head SHA, if you remember. So that's what we're going to use in here. So that's our URL, but in this case we actually don't need to pass in the PR number, but we need to pass in the file name, which we'll know. And we're also going to need to pass in the let's say yeah, let's just call it the ref, probably the easiest. Yeah, ref is there. Now we know this, all of them need to be a parameter. So let's go and do full name, string, file name, string, and then I've got ref, which is also a string. Now in Go, you could do something like this, right? Instead of doing this individually, I could just do something like this. This way I can say that all three of them are the string variables, but I'm just going to leave it as it is for now. Just more readable, I think. And then I'm going to do very similar thing in here, so call it a request. The reason I'm not communalizing this factory yet is because just want to like take you guys through all of this first before I do the whole unmarshal thing. It's just more easier to read. We can certainly make it more common and make it one function, but it doesn't really matter. It's a very small function anyway. It's more important that you understand it to the best capability, and I can explain it to the best capability I can. Right, so again, this is going to be a GET request, so get URL and nil. And we're going to set this token and send the request off. Same thing here, get the response back, and yeah, just do that. Let's copy all of this in actually. Cool, so we've copied it all in, and now we're gonna have to basically, one thing I think I should have done, which I completely forgot to do, is differ, which we really should do. And let's do this after we do the error handling. So do differ resp dot body close. Oops, that is not what I did not want that. Gosh, body dot close, that's what I want. Yeah, if you remember my point about having open data stream can cause memory leaks and things like that, so it's just a best practice to do, and you don't want to miss it. Right, so we're here. I don't copy it twice, don't need that. Let's pass in the writer again. We're also going to need the token, so let's pass them both in. So that's all there now. We're returning a nil, we're returning an error. Right, so in this case we're actually going to get a string back, so I can go ahead and do that for sure. Again, same thing, let's do string, comma, error. Now string is a bit interesting, so nil doesn't really work with string. So you'll see nil is going to be a problem. So instead of that, we just need to do empty string. So get rid of that and do this. Get rid of this and do this. Yep, cool, we are here. Ignore this for a sec. That's because we're not doing a final return if everything is following the happy path. But yeah, so failed to get response from GitHub URL, that's fine. Failed to read response body, failed to parse JSON data from response body. The only thing here is that we don't really want to use this var. So let's kind of hold on to this for now, right? Because what we really want is what the content is going to be, how it looks like, just like we inspected others. Right now we don't know. So we'll come back to this actually. And the return, in this case, let's just do something like string body for now as the return. Yeah. And let's just do nil. Cool. So we're just first we're going to inspect what's happening to this string body. And instead of returning, we're also just going to do from.println, and we're going to just do string body. Yep. So let's go and pass the information in here. Pretty much the same. Here we're going to pass the file name, and then we're going to pass in the payload dot pull request dot head dot sha. We'll pass that in. We're going to pass that in, and we're going to pass in the token, and we're going to lastly pass in the writer. Yep. So that's all being passed in. Got content. I've got error. And I need to do some error handling here. So we're gonna go and say if error doesn't equal to nil, then come back down in here. Just print in here saying fail to get content for file, and then put a %s. This is just going to be file name. And as for content, let's just go and do something like .println. Let's just do content. Cool. So we are actually going to hit a breakpoint, or we're just going to let this run through basically. So go ahead and hit the play button on the debugger. Now that it's up, we're going to go back down, close it, and then just reopen it. And once it's up, we're going to go back down, and we can see that there's quite a lot of information. Right, so let's inspect this, right? So what have we got here? So you got the name, we got the path, we got the hash, URL, git URL, download URL. Right, and then we get a field called content, and the content looks like it's base encoded, which isn't the most useful. Okay, there's also a field called encoding, it looks like, which is saying it's base 64. Okay, cool. That makes sense. So it's a base 64 encoding, and we just need to decode it. Cool, that's not a problem. So let's stop this. Come back to our file content in here. Don't need that anymore. We know it's content. Okay, the return can remain like that for now, but let's go ahead and define basically our type here. Yeah, it's gonna be a single type, but still should be its own type. It's a file content, and let's say it's a struct, and let's just say we saw it's a content. It was a string that existed under the key content. So we're gonna go down in here, And in here we're going to do file content, and this is actually file content type. And now we are going to actually use this in that. So copy over the JSON on Marshall, and instead of files, we're going to pass the pointer to file content. Fail to purge JSON data from response body is still valid. Return nil, well, it can't be nil, it has to be string, just like the other ones. And we also have seen that it's base 64 encoded, so we're going to actually go and decode it. But yeah, also should add the differ statement here for resp body close. Cool. So now let's go and actually get the data that we need, which is, so we're going to use the base 64 module, and we're going to use the standard encoding method to decode it to string. So pass in the file content, right? So what it does is that, so this method particularly, it takes in a string as an input and returns a encoded slice of bytes, of which we can just easily string convert back to the actual content, right? So we have passed in the content from which gets stored on the file content type basically, and then from that we're going to have a data variable populated with the slice of byte. Let's do some error handling here. So if error doesn't equal to nil, then we're just gonna, this is not really a HTTP error at this point, so I'm just gonna do from printf, and we're just gonna say fail to decode content for file, let's put %s, and we're gonna do file name, and then we're just gonna do return string, empty string, and just error. Now that's our data, and instead of string body, we're just gonna do string data, and I will show you in a sec how that looks like. So where are we? So that's our content in here. So the content should be basically a string containing the actual content of that main.go file I added. So if I go ahead and just run this now, and I'll actually hit a breakpoint here. I'll go in, close the pull request, and I will reopen the pull request. Come back down in here, and you can see what the content is. So I'll actually print it out in the debug console. So you can basically see that it's got the package webhook import and all that, which is coming from that Go file that I added previously on that test repo, right? All that's come back and come back as a string basically, which we are now going to take and send it off to the large language model in AWS. Cool. So let's go and look into that for a bit. By that I mean the actual AWS Bedrock from AWS console. So we'll leave it here as it is. So let me go to browser now and give an overview of AWS Bedrock. So AWS Bedrock is basically the Gen AI platform within AWS. I use it quite widely with my work, also in my personal projects, and it's great. I've also worked quite a lot with Google Vertex, but I personally prefer AWS Bedrock more. And essentially, I'll just give a quick overview of it. So you've got a model catalog in here where all the foundational models are. You can request access to all of them if you wanted to. Like I've got access to some, like the Claude 3 Sonnet, the Meta Llama 8B, for example. Then you've got a whole lot of cohere choices, DeepSeek and all that as well if you wanted to. Then there are custom models if you wanted to do that. And this is like your playground, so you can basically select a model, send a prompt to it, and see how it's behaving with that, right? And based on that, you can choose a different model. But these are more like fine-grained use cases for Gen AI, which in a professional environment definitely is going on quite a lot now. There is option for image and then agents. So agents is quite widely I use at my workplace. And what agents does is that, so you can have agent for multiple languages in this example, right? You could set up an agent that only looks at Go related source code and optimizes that and improvises that. You could have an agent for Python focused code, right? You could have an agent for just TypeScript or JavaScript focused code that optimizes it. The benefit of spreading them out is that you can configure each agent to focus on particular specialization, right? So that they can just solely focus and improve that better. Although there is nothing stopping you from doing it all through one agent. It's all about how you want to maintain and fine-grain your Gen AI solutions, right? There is option for knowledge base, which in a future video I'll cover, but this is basically a way to integrate a private knowledge base. So let's say if you ever go into, for example, web chats, right? Let's say a travel agent. Most of travel agents nowadays, there is a virtual assistant that comes up with some information, you answer it. And all these things currently nowadays are being powered through these Gen AI solutions or Gen AI platforms. And knowledge base is the way to do it. And then there's a prompt management. So you can basically, because prompt is a crucial part of how your Gen AI models are going to behave. So prompt management is a key aspect of it. And you can sort of create a prompt, version track it, and manage it, right? And you can then choose which prompt your agent should be using for what. And then you've got these guardrails. What guardrails do is basically make sure that, right, as an AI model, there should be some control, or this large language model. And you want to make sure that some sensitive data for your use case is not being leaked. Which is very relevant in a corporate environment and in production use cases. You don't really want to just let a large language model loose, where people, especially if it's customer facing, there are a lot of requests coming into it. So you need to safeguard it. And that's what this is for. Now, all of these are like different parts. There are quite a lot of interfaces in this massive platform of AWS. So I use Terraform at my professional environment to manage all these things. So I've got versions of different agents all managed to Terraform. I've got knowledge base, the data source for the knowledge base, which could be like a raw data from JSON based on JSON files in S3 bucket. Or you could have, let's say, a vector store, right? So you could have vector store like Pinecone. You could use something like AWS's own Open Search service as well as the vector store behind it. Right, so all of those you could manage and spin up through Terraform, which would be really, really useful in a production environment. And then you can also define how your prompts are provisioned and version tracked, all managed through Terraform. And yeah, you can control your guardrails that you set up to Terraform as well. But we're not going to touch the Terraform's aspect of managing these things in this series, but I will make a series in future where I'll walk through how to manage and provision all the Bedrock ecosystem through Terraform, as it's very useful in a production environment, especially nowadays. Right, so now with that in mind, let's go. So we're going to, as our large language model, we're going to use the Meta Llama 8B instruct. Personally, because I've worked with it quite a lot. Also, another thing to keep in mind here is that if you're actually trying to follow along and set up these LLMs, you are most likely going to need to sign up with an AWS account. I'm not 100% sure because I already have an AWS account, so I never really had to go for the free version. So I don't really know how Bedrock works. So it's something you'd have to investigate, I'm afraid. But I'll show you and I'll walk you through how it would work if you had access, right? So the first thing to do here is that we're going to essentially create a new sub package, right? So let's clear this off my console for a bit. And let's come back in here. Let's close this end file and let's create a new folder. Let's call it Bedrock. And in this Bedrock, I'm going to create a new Go file, call it bedrock.go. And in bedrock.go, I'm basically going to set up the Bedrock client here. So that's essentially, so if I do first thing, package Bedrock, just like I did with the webhook. And the first thing I'm going to do, because I'm going to need a region to actually interact with AWS. So I'm going to say, so a disclaimer, I'm based in London, based in the central London in here. So I'm just going to put my spot as EU West 2. And then I'm going to type in, so before I do that, I'm actually going to show you guys a couple of things. So let's go to AWS client library and show you what I actually mean. And we're going to actually try to follow along from them, because that's what you do. Because I've already worked with it, I would know those packages, but I just realized I should take you through how it works, right? Okay, we don't want the Bedrock Go client. Actually, let me get a runtime so I can explain to you what it is, what's the difference, right? So this is basically some examples on how to use the SDK for Go to interact with the AWS Bedrock API. Now, you see there's two things. There's AWS Bedrock and there is a Bedrock runtime. Now, Bedrock is basically just more of like, you can think as a read kind of API. It allows you to list, it allows you to get things, but you can't actually run anything against the large language models using this. Whereas with the AWS Bedrock Runtime Go client, you could. So we're gonna go and follow the way how they're invoking foundation models, right? And let's actually go, let's go to this scenario and see what they're doing in here actually. So we can see the Bedrock runtime, and let me actually open up something. Just trying to let's look at the Cloud one. Yeah, so we're not going to use Claude as our LLM. Like I said, we will use the Meta one, but we can borrow a lot of those things from here, regardless. So the first thing we want to do is actually go back to the top in here. Right, we need this. The first thing we're going to need here is going to be a thing called context, right? Which comes from Go. So let's go and create a function first of all. Create a function, let's call it invoke model. The reason I capitalize the first letter, as you've noticed, most likely is because I need to use it in my webhook package where I get the content and then pass it off to the model. So I know my prompt is going to be a string because I'm returning a string for as the content. So I'll leave it like that as the argument. That should be really the only one. And here, let's go and set up context. So context, and I'm just going to do background. Yeah. So context module and the background method in here is basically top level, as it says basically. So top level context for incoming requests, and we are then gonna now set up SDK config, and we're gonna put error. So config, and you're gonna see these modules like that auto kind of populated in the import section as well as you go. So we want to do default config, right? And we want to pass in the context to it, and we're going to do config with region. Now, if you're not familiar with AWS, I'm going to give some information on it, which is essentially, so first of all, this is getting highlighted in red. That means I basically don't have that module as a dependency for my GitHub bot module. So what I want to do is go to the directory and do a go get, right? And that will make sure it gets added. Now I go back to the code, right? So what load default config does, so this config is coming, as you can see, from the AWS SDK, and it's a way to make sure that it picks up my default credentials. So if you're in AWS, you are most likely setting up these two envars, right, which are called AWS access key ID, I believe, and then there is another one, AWS access key secret, basically something like that. Now these two are already set in my variable, and that's what it's looking for, as in that's what this load default config is looking for. So once it finds it, based on my context, which in this case is basically my environment, my local environment, it then pulls out these local credentials, and then it sets the region for that as EUS2, which is what I've defined in here. And that way I've got my SDKs, the SDK configuration that I'll be using within this Bedrock package is set up to use my local credentials for AWS along with the region set to EUS2. And now I can actually, let me just do some error handling before I go further. Because if this is running into an issue, then I'm just going to be actually doing a println, and let's just do error and then whatever the error is, basically, because I don't know what exactly the error could be. Since my local environment, there could be a few different things. But given that it's all good, I just want to then get my client. So my client is basically going to be from Bedrock runtime. Oops, it's not capital R, it's runtime. And I'm going to do a new client from config. And I'm going to pass in my SDK config in there. So this way, the new client that I'm generating based on a configuration of my SDK is already going to be set to use my credentials and my region. And we are also going to have to do a go get on this, because I haven't got it at the moment. Oops, I don't really need to deal with that. So to go get, and let's just do a clear to clear things up here. So I go back to this in here, my Bedrock runtime. I've got it, and let's just define some. Also want to define a constant in here. The constant is going to be a model ID. So the model ID is just going to be a string. So I'm gonna go back to AWS Bedrock, and I'm gonna copy so this is the model ID. So you just need to go to foundation models. Just quickly, I'll show again. Then over here, you'll find your model. Click on it, and once you are on it, then you just need to basically, oh wow, it's a bit slow. Yep, it's back. So let's just copy it, and I will then just paste it in. Oops, string. So you have a string, and you can also add in some prompt as a constant. So let's say prompt prefix. It's a good idea to give some prefix or some context to the prompt itself when you're sending it. Now, providing context and things like that, I'll cover later in my video series about solely focusing on Gen AI, where I use LangChain to kind of chunk through the data, and make sure that the right amount of, not the right, but the best amount of possible context I can pass through, depending on the max number of tokens for the model. So all that stuff I'll cover in a future video where I'll be working with the Llama model locally, or a DeepSeek model really, or one of the GPT for all, or a GPT for all model. But stay tuned for that. Those will be separate video series. But in here, I don't want to jump too much in depth into that. So here, think of it just like a prefix to kind of, help the AI model with some context, right? Think about if you had some context on a question, or before a question was asked to you, you'd be better placed to answer that, right? So same with the large language model. So provide me suggestions on how to improve this code, put a colon, and then we're basically going to add that together with our actual prompt that we've got in here. So now let's just do something like wrapped prompt, and that is equal to, let's say, our prompt prefix, and let's say our prompt, which is getting passed in as a string here. And then we also need to do request, right? So the request is going to be, so for this we're going to need some types now. So let me just quickly go back to the examples that are showing in here. Sorry, it's in the runtime. So we basically need something like this. So let's go and go in. Now this documentation, since Bedrock is pretty new and they're iterating on it quite often, it's pretty old. When I first started, it was the same documentation and they haven't really gone and updated it yet. But I will kind of tell you what to do. So first of all, this is Claude, and I said that we're going to use the Meta model, right? So let's rename this Meta. And here it's going to be a Meta response. And different models are going to have a different level of response. You can see more about it in the actual usage of it. There will be more documentation around interacting with different sort of model, not just here, but within the AWS SDK's contribution. So you can find it more there. So you can find more about it there, but in here we're going to get rid of this. I know for a fact with my experience with Meta, it just prompt the expect, and this is also not completion. This is actually generation. And I'm gonna get rid of this. If you didn't know this, you just have to basically go to the docs and you'll find it. And then client wrap prompt. We're pretty set now, so let's go and set up a request. So just like we did kind of with the HTTP stuff, we're going to set up a request. So this is not gonna send a request, but we're gonna set up or create a request object, you can say. Keep prompt, and we're gonna pass in the wrap prompt, right? So what are we doing here? So we're basically saying that I've got a meta request type, and this request type is what I'm gonna send as my request. So now we're then gonna do, let's do body again, and we're gonna do some, so this is going to be the fact is that we're going to use the client library, but the client library under the hood is going to be sending a post request to the large language model with our prompt. So that's why I'm basically setting up a body. And now you've noticed that I've done like JSON Marshall. Now what JSON Marshall does is the opposite of unmarshall. It basically converts the data. It takes in JSON input and then converts it into a byte slice, as you can see in here. So it actually does the JSON encoding, whereas JSON unmarshall, you can think of it like it does the JSON decoding. So if there is any error here, let's handle them. So if error doesn't equal to nil, then we're just gonna go and we're gonna do print. Yeah, let's just do println in here. It's not really a HTTP error or anything like that, since we're really dealing with client libraries. Couldn't marshal the request, and let's just basically say that this is our error. And once we've done that, we're then actually gonna now invoke the LLM. So given that our body is all good, like we could actually marshal it fine, we're gonna send that off using the client's invoke model. So the invoke model basically takes your context, and it basically is used to run inference, right? The inference is essentially just the LLM getting passed with a prompt and it coming back with a response. So we're going to pass in the context because these are the params it's asking for, and then we're going to pass in a pointer since that's what they're expecting. So let's go in and pass in Bedrock runtime invoke model input because that's literally what they're asking for in here. And that is going to be basically a struct, and we're going to say model ID. So aws.string. So this is the AWS package or the AWS module, and in here we're going to pass in our constant model ID that we defined. So let's go and actually split it out like that. We're also going to need to add content type so that it's in application JSON format. Again, AWS string you want to do, and you then want to do application dash JSON, and then you want to pass in lastly the body. It should be capitalized. Yep. Okay, cool. So is this actually closed properly? Yeah, this is closed properly. What's the problem here? One sec, let me just think. Yeah, it didn't like me separating it out like that. Let me just all put it back together for now. Oops. Should be like this, really. Yep. So that's how it is. Result, and I'm invoking the model. It's coming back. I'm invoking the model with all this information, passing in the body, content type, result error. So let's talk about this whole invoke model input, right? And I'll show you manually as well how it's actually basically working. So let's open this up. So what this is expecting is that you pass in a unique identifier of a foundational model that we saw on AWS Bedrock console earlier, and you then basically, after you passed in the model ID, you passed in like what type of data format you're passing into the model, or what's the, like in my case we are passing in the data in a JSON format, hence I put the content type parameter that I'm setting, and lastly, right, what's the actual prompt that you're passing in my case that's the body. The body has to be encoded in whatever content type that you're setting when in the content type parameter field here, right? Since this is an application JSON, I'm also encoding the data in application JSON so that can be perceived or that can be received by this model and decoded correctly to the prompt string that it needs to get to, right? That it needs to analyze and improvise. So that's what this invoke model input is doing. So now let's just go and handle some error in here. So if error doesn't equal to nil, then we're saying basically that, okay, there's some issue. So if I do format dot print len, and let's just say error when trying to invoke LLM model. And then we're going to put a colon and we're going to say this is the error. Okay, and here we're just going to do a return. And we should also do a return here. And finally, if it's all good, what we need to do is unmarshal the response back, basically. So I'll do response and let's do meta response, right? Which I said was generation that I defined. So the response that comes back from the model in a JSON format back is going to have a key called generation, and we just need to literally pull that out. So we're going to do our very familiar JSON.unmarshal, and in here we're just going to pass in the result.body, and then we're going to pass in a pointer to our response, and then we're going to do array error doesn't equal to nil, and if it doesn't, then we're just going to say that error encountered when trying to unmarshal LLM response. And we're then just gonna do very similar and pass the error in there, right? But if otherwise it's all good, we're just gonna return response.generation, which we know is going to be a string. Now let's come back to the model in here and say we're returning string, comma, error, right? So we should probably do return this nil here. Oops, that's wrong. That's incorrect. This is error because we encountered the error there. String, comma, error. Oops. String, comma, error. Yep. And last but not the least, let's do the same here. And return nil for error. Yep. So that's all good. Now I can actually come in here and invoke my model. So instead of this, let's do before I do that, let's me add. So if you remember how I imported it, we're gonna have to do something very similar here. Just instead of oops, copied the wrong thing. Copy this, paste that, just simply instead of webhook, point this to Bedrock. Can't really save it yet. So as soon as I've got auto saving on VS Code, so as soon as I save it, the Go formatter basically just gets rid of any unused imports. So what I need to do is get rid of that, do Bedrock invoke model, pass in content to here. Cool. Now we should actually get a response back, which is going to be a string, and we're going to say, let's call it LLM response. Bedrock invoke model, and there's going to be an error. You know that. I'm just going to go simple error handling. Say if doesn't equal to nil, then print when failed to get response from LLM due to error. Otherwise, we just know it's all good. So it's LLM response otherwise, right? Cool. So now let's go and actually, I'm gonna hit a breakpoint in the best thing to do. Right. Let me stop here to show you what the wrap prompt is, and let's go spin up our application here. once it's up, I'm gonna go back to the pull request. Yeah, it's here, so let's close it. And now let's reopen this. Right, so this has now come in here. Let's step over. Okay, so I got a wrap prompt. So let's me get the data. Wrap prompt. Okay, it's massive. So actually, I could have just copied the value from here. And I'm actually going to go into AWS Bedrock now. And let's go to this playground. Let's go to the chat. I'm going to select the model, which is Meta. Use the 8B instruct on demand. Apply it. Ignore all this. So temperature, top P, these are all properties. The more you know about Gen AI, the more familiar you're going to get. They basically configure how sensitive or probabilistic the LLM's response is going to be. But I'll show you how this basically goes. So what the action that I'm doing manually literally here, this is literally what's going to happen. So there you go. It comes back with a lot of ideas for me. So there's clearly quite a lot of input that it's got. So yeah, so it's basically working. Now let's just do it from code as well. Right, so let's just go ahead and run this through. So you can see all the data here. So literally what I saw manually in the console is the same thing. Here are some suggestions. New code, you're not handling errors properly, you're returning HTTP error but not actually returning the error. Handle it in a way that makes sense for your application, and so on and so on. Which so it's basically talking about this in here, which is actually very true. I will actually return the error in here, and then look, there you go. It says that it's all in one file, so I shouldn't really be actually doing it in one file. So I split that out, variable naming and not very descriptive. For example, oops, my battery is kind of going off. Let me